Hello, everyone. I'm Aksa Taylor, Chief Security Evangelist at Exaforce. We just announced our 125 million Series B, and I'm sitting here with the architects behind this platform, Exaforce. Today, I have our co-founder and head of engineering, Devesh Mittal. Devesh, thank you so much for joining me.
Thank you so much.
I'm going to ask him what really led to Exaforce standing out as one of the most well-funded companies in this crowded AI SOC market. How did he design Exaforce to be different and unique in this crowded AI SOC market? Devesh, can you please introduce yourself?
I have a fairly diverse engineering background. At different points of my career, I've worked on several levels of the technology stack, starting all the way from the bottommost chip design, ASIC design,
hardware,
CPU design, stuff like that. And then leading from there to kernel, user space, cloud applications, and now cybersecurity.
How was that switch, moving from hardware to software, and why?
I've always been a curious person, and once I understand how something works, the next questions are how does the next layer work, and then the next layer, and then the next layer. So that led me to explore what people were running on the CPUs that I was designing, and that naturally led me to lower level software and then higher level software. The other side is that I always wanted to understand the business problems that we are solving for the customer. Being in software gets you closer to the business problems, and you're able to iterate quicker and demonstrate value much more quickly.
So you're an engineer with a customer success perspective. Like you want to know what end user is doing. Usually engineers are like, I want to get this done, I want to publish, I want to push it, I want this code and this feature to be released. And you're thinking, is this feature really useful?
Exactly.
And I want to know what the end users are thinking about it.
Yeah.
How does your background help you in the role that you now have at Exaforce?
The fact that I've worked on the entire technology stack, and I feel grateful because it forced me to build the mental tools to work on really complex technology problems. And AI SOC happens to be a really challenging technical problem if you think about it. It involves building data pipelines, data enrichment pipelines, thinking of it from the customer's use case perspective, and then boiling it down back to how I would pull the data to solve this problem, and how I would index the data, enrich it, and so on. So because I have that view of how things work from the bottom to the top, I apply the same principles to the AI SOC, where it starts from fetching raw data and then taking it all the way to business outcomes for security analysis. So that ties everything together.
Nice. So you're bringing that, hey, I've seen how hardware to software translates, and now I want to bring that same end-to-end visibility to the AI SOC market.
Yeah.
Now, you mentioned something very interesting. You talked about how data pipelines, enrichment, all of this is a part of that platform. But a lot of times when we hear AI SOC, it's triaging, it's just bolting LLM on top of existing infrastructure and tech stacks. So it may not be easily understandable for someone who hears the word AI SOC to think about the data aspect in it. Can you explain to me what a true AI SOC platform is in your mind, or should be, and how you've translated that in Exaforce?
So we believe that data that's important from a security perspective for an enterprise involves both config and log data, because that helps you tie together the full story of activity, runtime, with what was happening on the config side, meaning that how are your entities in the enterprise structured, how they relate to each other, which identities enroll into an account, what groups are they part of, what roles do they get via those groups or directly, and then what do those roles give these identities access to? So which resources can these identities access? How important are those resources for the enterprise? Now, when we put all of this together, a lot of interesting security value comes out of it. From a security perspective, when you put this together, you end up creating a knowledge graph which represents all the entities in an enterprise. So the knowledge graph that this creates lets you ask really fundamental questions and get very high quality answers from this data. Right? Now, when you bolt on an LLM on top of this, you get 10x the quality because you've already created a structure from the raw data that really represents the security posture and the runtime in the same context for the LLM to reason on.
Now, playing the devil's advocate here, some people may say, why do you need to ingest data? Just triage what's already there in SIEM because that's enough data. You help SIEMs become more efficient, you reduce costs, you triage alerts that are critical, and don't become a data warehouse. What is the risk of not having this additional context, which for our viewers, we do play on top of SIEM platforms as well. So if you're just looking for triaging, that's possible too. But what is the additional advantage that defenders can get if they onboard more data sources and bridge this context?
Let's take a real example of an attack that recently happened.
Yes.
There was an attack where North Korean actors were joining companies and pretending to be American employees. And it was found many months later that these were in fact remote workers from North Korea using a VPN and posing themselves to be American actors. And their goal was essentially to scrape the organization of sensitive data, look for things that didn't really agree with their job descriptions. They would go in to Google Drive in different folders, start cloning repos from GitHub, which they are not supposed to be working on. This is a great example for why we need configs as well and what the knowledge graph would do. A knowledge graph in this case, would create a map of the enterprise, figure out who the peers of this identity are.
Peers, not just the identity,
Not
but
just the identity.
others in the team.
Others in the team. We would know who these identities report to and figure out that, okay, these are the people in the same team reporting to the same manager. We expect some similarity of behavior between people of the same team. We can then perform our analysis saying, hey, this person joined 2 weeks back, has been cloning 3,000 out of 3,500 repos from GitHub, whereas his peers in the same team just work on 5 repos. And so why is he cloning all those extra repos? We also look at their Google Workspace activity, say that, are they overly interested in sensitive files? Are they going beyond what their peers usually access? Are they just scraping for, just browsing folders within the drive and trying to look for sensitive data there? So we put all of this context together and then we flag identities which could be insider risk and use that context in alert triage and detections. And that leads to much better SOC outcomes at the end.
I love it. Trust Vibes, our next campaign on identity. Follow us to learn more about how we do this identity piece. But Devesh, the SIEM platforms, on the other hand, are you saying all this information and context would not be picked up there, or what would be picked up there? Is that why it took months for this activity to stop?
A SIEM is typically ingesting logs, and logs tell you a lot about runtime activity. But without the enrichments of who this identity's peer group members are, it's very hard to create the baselines in a SIEM, right? For example, if I ask a SIEM a question of what repos should I expect this person to clone once he joins a team, it's not straightforward.
Yeah, there's no prediction because there's no historic data of the peers at all.
And the fact that how would you even figure out who the peers are? That will come from a config that you fetch from maybe an IDP or an HRMS system, which tells you that this is the manager for all these people. And then you figure out, you walk the graph and you figure out that these are the peers of this identity.
That is a very straightforward use case. So if these organizations had Exaforce, do you think this activity would be triggered, like how faster? Because by the time they detected it was a couple months.
As soon as a new employee joins, their activity starts showing up in our system based on the activity
and
logs.
And
this mapping just happens immediately.
So you don't wait for like 90 days to learn and then try to map back, because that knowledge graph is already there based on the peer activity.
Exactly.
I think this is where the user behavior analytics is different, because UBA or user behavior analytics usually focuses on that person, that identity, their baseline anomaly, or something that happens later on while they were good in the beginning. But this is a flip of that model because they might not be good from the beginning. They might just be an external actor with the sole purpose of infiltrating your organization. So a behavioral model will never look normal, or maybe in the couple days in the beginning, but still there will always be a flux of anomalies.
Yeah.
And in that case, having this knowledge graph that already has what this person's supposed to be doing and then map it with what he's actually doing is so important.
Yeah.
Devesh, you worked extensively on the detections piece of the platform. And can you tell us how you designed detections to be focused? And you talked about the knowledge graph, and I understand the anomalies part, but what about detection rules? How often are they updated? How do you triage Exaforce's detections versus third-party detections? Can you talk a little bit about how that works?
The philosophy that we follow for detections is that all entities in an enterprise, when we analyze their activity and the knowledge graph around them, it bubbles up signals of the following types. It has risk signals and threat signals. Risk signals are essentially measuring how exploitable an entity is and what is the blast radius of that identity. So if something goes wrong, what is the impact that it would have on the security outcome? And threat signals are behavioral signals which we analyze runtime logs for. An identity may not be an MFA enrolled. That increases their exploitability score. An identity might be an admin in Okta or an admin in some other application. That increases their blast radius. And if the identity has been performing activity which is deviating from their typical behavior, and this is measured with hundreds of conditions. There are many signals that we measure. Do we see impossible travel? Do we see location anomalies? So all of these signals are then put in the same context, analyzed together, and that leads to generating a candidate finding, right? And this candidate finding is taken through more stages of filtering, where this is combined with our knowledge model. And the knowledge model then combines this finding with much more context about that entity from all the other data sources in the system. And then it would finally say whether this is something worth looking at. At the end of all of this analysis, the alerts that get generated are really high quality, with complete explanation for what was analyzed and why we thought that this is something that needs investigation.
And Exaforce does this beyond identities. We go into the code and other factors as well. Can you describe what are all the other factors that Exaforce takes into account?
So we analyze activity on resources. For example, if a repo was made from private to public, and we saw a bunch of clones happening to those repos, and then suddenly it was made back to private from public, then we would investigate what really happened there, right?
Right.
Was it done intentionally?
Right.
Or was this done by an actor who was trying to cause damage? So this is an example of a resource-based analysis that we would do on the repo itself. There are others where we track file copies in Google Workspace. If you want to share a file with some external user and you're not an owner of the file, you cannot directly share it. But you can always make a copy of the file. And then you become the owner of the copy and you share the copy.
That's very detailed.
Yes. So we analyze this behavior on the file and we would trigger a finding on it.
That's why the Exabot messages me on Slack whenever I'm working with vendors.
Yes.
Now let's talk about Series B. This is a very big moment for us because investors, prospects, customers, everyone's eyes are on us. $725 million valuation. That is a big number to live up to, and the expectations are only going to get higher. What are some things on top of your mind as we enter this new phase?
So the first thing is it's huge validation of the architectural choices that we made in the beginning. We are seeing that the approach we chose and the decisions we made in building the product are paying off, because the more customers we interact with, the more feedback we get is that what we're building really helps them in their day-to-day work. It really is a force multiplier for them. It's huge validation in that sense.
Of course, for sure.
The other thing is that what this Series B enables us to do is to continue expanding the capabilities of the product because attacks are getting more and more complex. The number of attacks in the past few months has increased rapidly,
Exponentially.
and we want to continue building a lot of capabilities. You'll hear a lot of announcements soon about the product, about what we are adding in terms of capabilities. So that's the plan.
So maybe give us one sneak peek for our viewers as an early sneak peek of what you are building that revolves around IOCs. Maybe you can give us a hint of what's about to come.
We've been looking into insider risk very seriously. That has been a persistent attack vector that a lot of our customers care about. Even though our existing threat detections work pretty well in identifying behavior deviation from normal, we are building a part of our system which would analyze things specifically from an insider risk perspective and figure out or bubble up identities which seem like insider risk. Another interesting feature we're building is to be able to learn IOCs and attack patterns from all the attacks that have happened in one customer, gain learnings from those attacks, and apply those learnings to all our customers. This way, our system becomes self-learning. It learns from all the attacks we've seen across customers and evolves itself in being able to protect against similar attacks in future. So this happens by automatically identifying IOCs, indicators of compromise, and bubbling them up in with all the context around them to make them usable in protecting all our customers.
Exciting times ahead. And I know there's a long list of features that we can't reveal yet, but I'm super excited to be able to launch them. Okay, last question. What is one personal promise that you would like to make to the people listening to this, prospects thinking of evaluating Exaforce?
I strongly feel that config and log data is a goldmine of security value, which remains to be fully unlocked. What it takes to unlock the complete potential of it is very deep data analysis, a lot of creativity in how you would make use of it. And so my personal promise to the customers is that I would leave no stone unturned to unlock all of the value that this data has to offer from a security perspective.
Awesome. Thank you so much, Devesh. Appreciate it.
Thank you.
Thank you all for watching, and stay tuned. We have lots of big announcements coming as well that you do not want to miss. And if you're thinking of evaluating AI SOC platforms, give us a chance. This might just be the decision that sets the stage for your entire security strategy in this year and the years coming. Thank you.